Hello everyone, my name is Farhad and today I am going to present NLP tools for predictive maintenance records in MaintNet. This is a joint work with Travis Dessel and Marco Sampieri from Rochester Institute of Technology. In today's presentation, I'm going to talk about the maintenance data and what is our objective and the features in the MaintNet. Next, I'm going to talk about the language resources, pre-processing, text clustering, community contributions, and finally maintenance system demonstration. So what is a maintenance? Maintenance is a traditional way of maintaining equipment, software, or system, which usually performed in the form of scheduled maintenance, where the crew or engineer they schedule maintenance, and if they notice any problem during the maintenance, they write those issues. This form of maintenance also helps to build up the historical maintenance data for the system, such as the aircraft. However, performing scheduled maintenance may result in a developing a risk, such that if there are any issues occurs beyond the scheduled maintenance, we are not able to address those issues, and that can be costly. The solution to this is predictive maintenance, which prevents the needs for scheduled maintenance. However, for us to be able to develop the predictive maintenance system, we require to process those unstructured historical maintenance data. For this reason, we are presenting the MaintNet, a collaborative open source library for predictive maintenance language resources. Our objective in the MaintNet contains the creation of a novel language resources such as a dataset for technical language and exploration of different NLP methods for maintenance and technical dataset, development of the pre-processing pipeline to clean unstructured historical maintenance data, creation and development of a manual curated gold standards, development and evaluation of several pre-processing tools such as the limitizer, and finally, comparison of the clustering methods and the similarity metric for the maintenance text mining. MaintNet currently features a 7 English dataset from a various domain of aviation, automotive, and facility, which we can see that they contain a different instance and the token size. This is an example from the aviation dataset, and as we can see that it contains the domain-specific words and domain abbreviated words, and also misspelled words as well. In a nutshell, the nature of a maintenance dataset is that it contains usually text from a specific vocabulary, and sentences are usually compact and descriptive. They range the length between 2 to 20 tokens, and the problem and action and note are usually consist of a single sentences. And the other problem is that they usually contain the abbreviated and specific words and the misspelling and the drop words as well. The main other problem with the maintenance dataset is that the lack of the annotated data to perform the effective predictive maintenance, and also lack of access to such a sensitive data prevent us to be performing the effective predictive maintenance. To be able to pre-process these unstructured historical maintenance data, we developed the 4 phases of the pre-processing pipeline, which contains the handling the input data and pre-process them and cluster those unlabeled dataset and then evaluate and generate the labels. And for instance, in the pre-processing, we can see that we start with the domain, noise entity removal, and dictionary standardization, where we can see in the dictionary standardization, we first correct the misspell, and we also correct the misspell and the drop words. So be able to, in the MaintNet, to be able to convert those domain abbreviated words to the standard format, as well as the correcting those syntactic errors and the typos, we decided to empirically analyze a different spell checker, and such as the enchant, to see that if we can able to convert these syntactic error to the correct standard format. But regarding the result, we can see that they are unable to handle these kind of syntactic errors or the domain abbreviated word. For this reason, we developed the Levisham-based spell checking, which we can see that they outperform the other spell checking algorithms. As the maintenance dataset, it contains a different grammatical form of words which used by the crew or engineer. And also, it contains a different form of words that are different in the syntactic categories, but usually they are semantic related, such as the broken or break. For us to be able to have a consistent grammatical tense over all of the document, we use the lemmatization to reduce these different words inflection. And we decided to use the WordNet. And as we know that for performing the WordNet lemmatization, we require to define the part of speech tagging at the beginning. But as we can see that if we select the part of speech tagging, for instance, as a verb, we are going to get the outcome as incorrect informations. To be able to us to fix this problem, we created exception list that we feed to the WordNet lemmatizer, and we're able to lemmatize the words based on the correct part of the speech tag. So now I would like to present our results. So for a domain-specific spell correction, we compared the different spell checking algorithm with our developed Levisham-based spell checker on a 500 instances per domain dataset. And we can see that the Levisham-based algorithms, Levisham-based spell checking algorithm outperform the other spell checking in each domain dataset. We also further empirically analyzed the different sample of a document and to be able to see that how the general preprocess algorithm able to handle this dataset, and we can see that MaintNet preprocess outperform the general preprocess algorithms in terms of extracting as much as information and preserving the important domain words as well. Finally, we manually curated gold standard for performance evaluation of the part of speech tagging or clustering, and these gold standard annotated by the North American English native speaker using the Pen tree bank tag set. And this is the example of a gold standard instances. We further compared the different part of the speech tagger of the NLTK, Stanford, and text blob on a raw and made a pre-processed version of a gold standard on a 500 sample. And as we can see that the Stanford part of the speech tagger outperform the other, and also there is additional 4% of the accuracy when we are pre-processed by using the MaintNet. Now I would like to present the MaintNet website. In the MaintNet under dataset, we can find the three domain of aviation, automotive, and the facility. And if the user want to download and access the gold standard dataset, they can use this link. In the aviation case, we can find the abbreviation, morphosyntactic information, and a term bank dataset through here. Or if the user decided to download the annotation dataset, they can use this link. And if they want to modify the dataset, such as accessing only engine-related dataset, they can perform the download and they can modify through in here. And they can download dataset free. We also made our codes and algorithm free in the MaintNet, and the user can download this dataset for free and they can apply on their own dataset. And if the user decided to also download the entire package of codes and algorithm for each individual domain, they can download or view through this download section. So as a conclusion, MaintNet provides a technical logbook dataset of different domains of the aviation, automotive, and facility. We also developed and made it available of the abbreviation list, morphosyntactic, and the term banks for each domains. We also developed the pre-processing tools and evaluate them and made them available in our website. We also performed the intrinsic evaluation and comparing the different spell checker on 5 of the 7 datasets in the MaintNet, and we also compared the raw and pre-processed version of the maintenance dataset on the part of the speech tagging as well. We also developed a manual annotated gold standard that are available via our platform. And for the future, we are investigating other data cleaning methodology for further improvements. Thank you so much and have a nice day.